Hello everybody. In this video we will learn Chapter 7, Equity Markets and Stock Valuation. And by learning this chapter, we will learn how to compute stock prices based on future expected dividends and dividend growth. We will also learn how to identify differences in common stock and preferred stock, and we'll also be able to see how the stock market works. That's what the chapter is about. And in this video lecture, we would focus on 7.1, which is about common stock valuation. The rest of the chapter, you can just check out these topics on the textbook. So why don't we try to focus on the difference in terms of bond and common stock valuation. So to be able to value both bonds and common stock, we would need three ingredients. And the first is cash flow, time horizon, and also the discount rate, the interest rate. And for bonds, and of course, by doing so, we will try to take the present value of all these cash flows at the given discount rate, so that will be equal to the bond value and also the common stock value. So for the three ingredients of the bonds, these are the important characteristics. So for cash flows, all these amounts are known and fixed. So before even just investing in the bonds, you would know how much like coupons and how much par value or face value would be provided from this bond investment. So everything is just crystal clear from the very beginning. And also in terms of the horizon, the time period is fixed. It's finite. So there's no uncertainty in the time horizon as well. And in terms of discount rate, in real world cases, it's a little bit more complex, but at this level, it's assumed to be known. However, the situation is quite different with common stock. So first, with cash flows, the amount of cash flow to be provided from this stock investment, it's unknown. And also it can be varying. So for example, the cash flow you are expecting from the first period and the amount of cash flow from the second period, it's supposed to be different. It's rarely the same amount. And not only that, it's unknown. And in terms of the horizon, the time horizon is infinite. So for example, this one has to do with the going concern of a company. So a firm is assumed to be living forever. So that assumption makes time horizon or the investment period infinite, at least in theory. And also the discount rate, of course, it's more complex in the real world, but it's assumed to be known, or it's just provided to you as well. So if we just focus on common stock valuation, so what are these three ingredients? What kind of adjustments need to be made for these three ingredients? So first, with cash flows, we're not using just cash flows, just random cash flows here, but we are going to use what's called dividends. Okay, dividends are going to be the cash collection down the road. And in terms of time horizon, yes, it's going to be infinite from now on. And and for discount rate, which is assumed to be known, we're going to use what's called the required rate of return, or sometimes called expected return. How to compute this? Of course, for this chapter, it's going to be provided to you, but how it's actually measured or how it's estimated in the real world, that will be discussed in the following chapters. So to better understand common stock valuation, we would first have to focus on the first ingredient, which is cash flows. So cash flows, if you own a share of stock or if you just invested in a share of stock, you would be able to receive cash in two ways. First would be with dividends. Okay, if you invested in a share, it's likely that the firm will issue dividends, will distribute dividends back to the investors, and that's one form of cash collection. And the other form would be capital gains. So what that means is if you originally purchased a share, you would most likely sell those shares again sometime later. And at that point, the price difference will be your capital gain. So these are the two sources of your cash collection. And given so, if you just focus on these two streams of cash flows, your stock price, which is supposed to be the present value of expected cash flows, it's supposed to be the present value of expected dividends and capital gains. So you find that it's just, you have two different cash sources. One is dividend and capital gains. And what you saw in the cash common stock valuation was only dividends were mentioned as the cash flows, right? We're going to reconcile this difference with different exercises from now on. So let's start with a one period case. So let's suppose you are thinking of purchasing one stock, and it's likely that they will pay you a $2 dividend in 1 year. So you're going to hold on to that stock for 1 year, and by the time you are just selling it away, they will provide you with a dividend of $2. And you are supposedly thinking that, expecting the stock price will be $14 when you sell it away. And the required rate of return is 20%. So that this is just, if you don't understand this term, don't worry about it. It's just like a discount rate. It's just at this point, it's just given to you. So what is the maximum you would be willing to pay? So given so, your stock price or your stock value is supposed to be the present value of all the cash flow streams that you are foreseeing. So in 1 year, you're expecting dividend to be $2 and you will be able to sell it at $14. So these are the price streams that you're expecting. If you just take the present value of these cash flow streams, and that should be equivalent to the stock value or stock price. So let's just do the calculation, which is very simple. So I'm just going to use the formula for now. So 14 plus 2, which is expected in 1 year, you just take the present value of it by discounting at 20%, 1 plus the discount rate of 20%. And the price is going to be equivalent to $13.33, okay? So the maximum price you're willing to pay, or the stock price is supposedly $13.33. So from now on, we're going to just extend the time period. So let's suppose you're holding onto the stock for one more period. So you're deciding to hold the stock for not just 1 year, but for 2 years. And then you're expecting the dividends for the first year was $2. And then if you just hold it for one more year, you're going to be paid additional dividend, which is worth 2.1. All right. And at that time you sell it away, the stock price is going to be 14.7. So these are all assumptions. So based on all these assumed values, how much would you be willing to pay with all these variables? So if you just draw the timeline, once again, the timeline, the time horizon is crucial here as well with stock valuation. So in 1 year, you're not going to sell it away. So the only cash collection will be your dividends, and it's going to be $2. And then you're further holding the stock until the end of the second period. And at that time, you'll be collecting the second dividend of 2.1. And by the time you're selling it, the stock price is going to be 14.7. So you're selling it at that price. What would be the stock price? So you will have to take this present value of the first cash flow stream and the second year cash flow stream. So if you just try to put that into a formula, then it's going to be 2 discounted at 20%. And in the second year, you'll be collecting $2.1 and $14.7. You have it in second year, so you'll have 2 discounted at 1 plus 0.2 to the power of 2. Okay, so don't worry about using the formula yet. I'm just showing you the process. Okay, don't worry about the calculation itself. You wouldn't have to worry about it at all. And also, if that were happening, so if you do the calculation, then it will be $13.33. Okay, so the maximum price you're willing to pay would be $13.33, which should be equivalent to the stock price. Okay, so now one more period extension. So 3 period case. So what if you decide to hold the stock for another year, for 3 years? And in the meantime, you'll be collecting another dividend. And let's suppose dividend 3 is 2.205. Okay, so that's another dividend you will be collecting in year 3. And by the time you are selling it away, it's going to be 15.435. This is supposed to be 3. Okay, so if you just draw this time horizon, you will see that in first year, you will be collecting $2. In second year, you'll be collecting 2.1. And then in the third year, your dividend collection will be 2.205. And then also when you're selling it, the price that you will be receiving is going to be 15.435. And then if you try to find out the present value of all the cash flow streams, then you will note that 2 discounted 20%. 2.1 discounted 20%, but to the power of 2 because it's paid out in the second year. And then the cash collection in third year, which is the sum of dividend and this the sales price, then you just discounted 20% again with the number of years 3. Then you will note that the stock price is 13.33. So you can see that as we are extending the time period, the same pattern is repeating itself. So until the last year, until the terminal year, your cash collection along the way would be just merely dividends. And finally, in the terminal year, meaning that, the point that you're selling it, you will have one more cash source, which is the stock price that you're selling it at, right? But in the meantime, you'll only see dividends along the way. So what if? What if we were pushing back the time that you're selling the stock? Then what it means is you're just pushing it away, pushing it back until like infinity. So meaning that you're not selling it at all. Then, the stock price of the stock, the price of the stock is just the present value of all expected future dividends, okay? So you're not selling it. So there's not going to be any sales price. It's just going to be the sum of all the dividends to be paid out forever. So even if you're selling it away, you're selling it to some other like investor. If you just think of investors as a group of body, okay, then there is no just sales going on, okay? If you just think of all investors as one group of body, then there is no sales. It's just going to be dividends just being paid out forever. So just putting that all together in one formula, you would see that the stock price is present value of all expected dividends to be paid out forever. So if you just express that in a formula, put that into a formula, you will see that only dividends that are being paid out forever and discounted at this given discount rate forever would be just making up the stock price. Okay, so if we could think of any kind of like a model that could articulate this infinite dividend payout, we'd be able to find the stock price or stock value. So the first question would be, how can we estimate all future dividends then? So that's why the cash flow being equal to dividend was the first ingredient of stock valuation. Given so, how would we be able to estimate all future dividends? So there comes another assumption. We would use a model based on assumptions. And the assumption is called the dividend discount model. And there are 3 different assumptions that we could add to the dividend discount model. First is constant dividend or zero growth. So we are in a sense just assuming that dividend is going to be constant, not changing at all. Growth rate of 0. So firms will pay a constant dividend forever. $1 today, $1 $1 in 1 year, $1 in 2 years, no change in dividend amounts. So this is a very radical assumption. And then price, if that were the case, price would be computed using the perpetuity formula. So it's going to be very, very straightforward and simple. But as you can see, this is very unrealistic. So let's make it a little bit realistic by making a little tweak. So number 2, constant dividend growth. So right now, firm will increase the dividend. Yes, it will increase the dividend or decrease the dividend, but that change of growth will be constant. So a constant percent will be applied. For example, $1 today, and then it will increase by 10% next year. And then the following year is going to increase by 10%. So the same 10% growth rate will apply to the dividend growth, but it will still increase or decrease. It will change. So in that sense, it's a little bit more realistic. Number 3, supernormal or non-constant growth. So we are assuming that the dividend growth is not consistent initially, but settles down to a constant growth eventually. So what we're saying is dividend growth will be like 3%, 2%, 4%, 5%. It can be any growth rate until a certain point. But at a certain point, it will slow down to a constant growth, say like 1% or even 0%. And it will not change from then on. Okay, so multiple growth rates apply. However, in the final stage, it will have to settle down to a certain point and it will just keep up that growth rate forever. So that's the third assumption. So as you can see, as we move down from number 1 to number 3, it goes to a more realistic version. Well, let's start with the least realistic or the simplest version, which is zero growth. So we're expecting the dividends to be forever at regular intervals. So what that means is, from chapter 4, what we learned from chapter 4, the perpetuity model could be applied here. So if we apply the perpetuity model, our price, so 0 indicates price right now. The price of stock right now is going to be equal to dividend, which is supposed to be constant, divided by the discount rate. So very simple formula should be applied here. Let's try an example, a very simple example here. Suppose stock is expected to pay a $2 dividend every year and the required rate or discount rate is 10%. What will be the price? So dividend is 2. Required rate of return is 10%. So your stock price should be 2 divided by 0.10, so 20. It's as simple as this. But as you can see, simple means it's unrealistic, not very often used or not practical. So we might as well move on to a more realistic version, which is the constant growth model. Note that the constant growth model is the most popular or the most widely used version. So we're going to take a look at this more in detail. And then the third one, which is supernormal or like multi-growth model, we probably might as well just skip that and save it for a different course. So let's take a look at the constant growth model. So a stock whose dividends are expected to grow forever at a constant rate, like supposedly G. For this stock's valuation, let's suppose a dividend that has just been paid, like right now in year 0. Let's call it D sub 0. And then from D sub 1 through D sub n, let's suppose these are the future expected dividends. With this information, if you wanted to figure out dividend in year 1, and that would be D sub 0, which has grown at the growth rate of G. So 1 plus G to the power of 1, or you can just omit this part, right? So that will be dividend in year 1. And then if we continue with this calculation, dividend in year 2, that would be dividend 1 grown at the growth rate of G. So 1 plus G to the power of 1. But if you take a look at D sub 1, that was actually, this calculation right over here. So D sub 0 times 1 plus G to the power of 1, right? So if you just combine these together, then that will be dividend 0 times 1 plus growth rate of G to the power of 2. So if we just generalize this formula, the dividend in a certain time period when should be equal to D sub 0 times 1 plus G to the power of n. Okay, so this would indicate the time period from year 0. So that would give you the dividend grown at a constant rate of G at time period n. So just take a look at this formula here, and then I just want to highlight one thing before we proceed to the next slide, which is, as you can see, dividend in year n, like this, which is just a reiteration of what I just wrote right over there. So as you can see, one really important characteristic that you can find is the subscript here. This base dividend subscript is 0. And then the power here is n, okay? And as you can see, 0 plus n is equal to dividend in year n, right? So if you are trying to figure out a dividend in a certain period of time, all right? If you want to figure that out, if you can use any dividend, all right? So dividend 0, if you start with dividend 0, and then you just multiply that by 1 plus G to the power of the remaining time period, all right? So for example, 0 plus n is equal to n. So whatever time period, whatever dividend you're using as your base dividend, okay, you multiply that by 1 plus g to the power of remaining time period, then it would give you the dividend of the period that you're looking for. For example, like dividend 1. Then you multiply that by 1 plus g to the power of the remaining time period until n would be n minus 1, right? And then you will have dividend n. Or maybe if you start from dividend n minus 1, for example, then the remaining time period until n is just 1, right? So then you just have 1 as your power. Then you will still arrive at the time period n. So you can just use some kind of variation here with the assumption that your constant rate was g. Okay, so this is just a supplementary piece of information, but this will be very useful as you go along. All right, so given so, let's try to use some example here. So suppose that your dividend at this time period was 2. Okay, in year 0 it was 2, and it's expected to grow at 6%. Then if you just based on this information, if you want to figure out dividend in year 1, then 2 that was just grown at 6% for 1 year, it will be 2.12. Dividend 2 would be just growing as it's compounded at 6%. Then it will be 2.2472. And dividend 3, which is being compounded at 6% for 3 years, it will be 2.3820. So let's just try to use that information for constant, stock valuation. So supposedly, if your dividends were growing constantly forever, then that could add value to our stock valuation calculation. In that stock price is present value of expected dividends, and dividend, which is supposedly just dividend 1, dividend 2, dividend 3, growing at a constant rate forever, could be rewritten this way. All right. So dividend 1 is supposedly dividend 0 times 1 plus g to the power of 1. Dividend 2 would be growing it like compounded twice. Dividend 3 would be compounded 3 times. And if we just add another mathematical principle here, this calculation, this formula can be rewritten as price being equal to what is written right over here. Okay, price is going to be dividend 0 times 1 plus g divided by the required rate of return r minus g, or maybe d sub 1, dividend 1 year ahead divided by r minus g. Okay. This is just another mathematical touch here, yet what you can see here is that the model has become more generalized and much more simplified than before. So this is the formula developed by a scholar called Gordon. So it's called Gordon model as well. And this is the model that we will be using for this chapter.